You know that feeling when you're trying to build something, maybe a bookshelf, a picture frame, or even just measuring out a piece of fabric, and you completely ruin the whole project because your measurement was off by just a tiny bit? It's chaotic, it's super frustrating, and honestly, as we're going to see in today's explainer, it is completely avoidable. Let's look at how we can build a rock-solid foundation in practical physics by actually mastering the very tools that define our physical world. Okay, let's dive into this. Here is our agenda for today. 1. Meet your measuring tools. 2. Unpacking the least count. 3. Steps for accurate measurement. And 4. The parallax error trap.
All right, starting off with Section 1, meet your measuring tools.
When we talk about measuring length, our source material highlights two primary heavy hitters, and they each have their own highly specific practical domain. On one side, we have the meter rule. This is your standard instrument generally used right in the laboratory for those controlled tabletop measurements. But what happens when you need to go bigger? Well, that is exactly where the measuring tape comes in. The measuring tape is specifically designed to handle much longer distances, easily capable of measuring up to several meters. So it's a pretty clean, practical distinction. The meter rule is for the lab bench, and the measuring tape is for the whole room.
Moving right along to Section 2, unpacking the least count.
Now this concept right here, it is absolutely crucial. It's really the bedrock of all scientific measurement. The least count is strictly defined as the smallest measurement that can be taken accurately with a specific instrument. Think of it kind of like the ultimate resolution of your tool. If you're a photography fan, you can think of it as the pixel size of your physical ruler. You literally cannot measure anything smaller or more precise than what this least count allows. It's a hard limit.
So what actually is that built-in limit for our everyday tools? It is exactly 1 millimeter. Whether you are using the laboratory meter rule or rolling out that standard measuring tape for longer distances, this fundamental limit of accuracy remains exactly the same. 1 millimeter is the absolute floor for reliable accuracy on these standard tools.
Now, what's really interesting about this is how it looks in practice. Looking directly at the text from our source document, it states plainly, the smallest division on a meter scale is 1 millimeter. That right there is your least count in the flesh. It's not just some abstract theoretical idea. It is literally the physical, smallest gap between two printed lines on your scale.
Okay, Section 3, steps for accurate measurement.
Based entirely on our source text, here's your foolproof, two-step procedural guide to measuring literally any object accurately. Step 1. Place the meter rule in such a way that its zero perfectly coincides with one edge of the object. And hey, a huge mistake people make here is starting at the physical edge of the plastic or the wood of the ruler. No, actually, scratch that. You have to start exactly at the printed zero line. Then, Step 2. Once that zero is locked in, simply take the reading in front of the other edge. Boom, that reading is the length of your object. Sounds incredibly simple, right? Zero on one side, read the other. But there is actually a major catch.
Which brings us to Section 4, the parallax error trap. And this brilliantly illustrates where perfectly good measurements go to die. Seriously, it's a trap. Look closely at the diagram from the source. We have an object lined up perfectly on a ruler. If you are looking straight down from point B, which is the correct angle, the reading is exactly 1.8 centimeters. But look what happens if your head is shifted just a bit to the left, looking from angle A. Suddenly, the object appears to line up with the 1.5 centimeter mark. That is a massive error. Or, if your head is shifted to the right, looking from angle C, the object suddenly appears to be 2.0 centimeters long. Just think about that for a second. The object hasn't changed size. The ruler hasn't moved a millimeter. The only thing that created these vastly incorrect lengths was the angle of the observer's eye.
So, the crucial point is how we physically defeat this visual trap. The source outlines a concrete rule to solve parallax error once and for all. You absolutely must read with your eye directly above the ruler, which was point B in that diagram. Or, alternatively, here's a great trick. You should tip the meter ruler directly on its edge so the printed scale is physically touching the object you are measuring. Doing this completely eliminates the visual gap that allows those sneaky trick angles to form in the first place.
Alright, so we've covered the distinct roles of our tools, the ultimate resolution of the least count, the exact chronological steps to measure, and finally, the visual trap of parallax error. We've seen how supposedly simple things are actually incredibly precise. So, to wrap up today's explainer, I want to leave you with this final thought. If simply shifting your viewing angle by a few degrees changes absolutely everything,